All right, hey Honors Chemistry. So I wanted to post a brief video on a combination of writing and balancing a chemical equation in addition to using LOL or potential energy diagrams to carry out or represent a reaction. So for let's look at this example. It says when you heat solid aluminum hydroxide, you decompose it into solid aluminum, hydrogen gas, and oxygen gas. And note the hydroxide ion I put here is OH minus. So aluminum hydroxide, aluminum would be Al3 plus, and hydroxide is OH minus 1. So if I were to write aluminum hydroxide, I would have to crisscross and I would only need one aluminum, three hydroxides. So when beginning to write this chemical equation, I would write AlOH3. And then it says it decomposes into solid aluminum, hydrogen gas, and oxygen gas. So solid aluminum, this was solid. And then we have to remember that it says hydrogen gas. Hydrogen from Brink or Hofbrinkel is a diatomic element. So I would write H2 gas and then into oxygen gas, O2 gas. And then I'm going to tell you right now the best way to balance this chemical equation. I'm going to shorthand this to make this a short video. This is going to be 2 and these both are going to be 3. And notice how I have 6 oxygens and 6 hydrogens on the left side, and now I'll have 6 hydrogens and 6 oxygens on the right side, and 2 aluminums on both sides. You would have figured that out if you used the particle diagram method or the guess and check method. Alright, and now it says I heat up this solid. So if I heat it up, heat is a reactant. And this is going to end up being an endothermic reaction, because I have to heat this up. Okay? Now, remember, I have to start somewhere with thermal energy and chemical energy. And I'm heating this reaction up. So if this is my Q, I'm probably going to have Q going into the system. I mean, I'm drawing a really large one, doesn't matter. Okay? I have Q going into the system. And in doing that, I'm increasing my thermal energy. And I have my chemical energy. And remember, we are going to be ignoring phase energy for writing these type of diagrams. We're just going to solely focus on the exchange between thermal and chemical energy. All right, and now what I have to do is now I have enough thermal energy to start getting my reactants to do things. So I'm going to transfer some of that thermal energy to chemical energy and end up absorbing energy overall. And this is how I would draw an LOL diagram for an endothermic reaction. I have my aluminum hydroxide. It takes in heat. Here's the heat that I was talking about. My reactants are my aluminum hydroxide. And then I'm going to have hot aluminum hydroxide. And then eventually I'll have my products, which are aluminum, hydrogen, and oxygen. Okay? Alright, so I'm hoping this very brief and short video is helpful as an example of what I would like you to be able to do with writing and balancing chemical equations and then using these potential energy changes in chemical reactions to represent energy. Okay? Hopefully this is helpful. If you have any questions or concerns, let me know.